Good morning, everyone. Myself, Dr. Gopal Arora. I am here presenting a lecture on green chemistry. This green chemistry is very, very important, and it is also known as sustainable chemistry. There are various types of chemistry: inorganic chemistry, physical chemistry, organic chemistry, polymer chemistry. What is what is all about the green chemistry? Where this word comes, green chemistry. Has played a vital role in the manufacturing of chemical products in various chemical industries. So, in the preparation of these chemical products, generally solvents and chemicals are involved, and even energy resources are also involved. So, what how can we design what innovative approach that we have taken for the manufacturing of chemical products, uh, so that this is not creating any pollution to the environment, or even prevent um, save our save our environment and human health. So for in this direction, this green chemistry arises. Uh, what is all about the green chemistry? Basically, this green chemistry arises to develop the innovative approach for the synthesis of products, chemical products, and even the what precautions we are taking uh, in order to prepare the products. And these products are environment friendly, eco friendly, and does easily dispose into the environment. So nowadays, many of the traditional methods are being replaced by the green methods or green approach. So we hope this lecture is important for all students, and this will give new approach to the students who are even going in this field to become a chemist. So in a chemist, as a chemist, they have to work in the direction so that they can reduce pollution, reduce number of accidents, reduce waste and all these things. So in this direction, this green chemistry is to be then green chemistry concept arises. So in this lecture we will discuss about the introduction part, and aim and goals of green chemistry, and what are the 12 principles of green chemistry that are suggested by the scientist, uh, and some examples are also covered in this lecture related to the green chemistry. So these are the contents: introduction, need for green chemistry, goals of green chemistry, obstacle in the pursuit of the goals of green chemistry, 12 principles of green chemistry. So green chemistry is also known as sustainable chemistry. As in the beginning I have told this, it is an innovative approach that aims to design chemical products and process that minimize the use and generation of hazardous substances. Means a chemist can design chemical products by using these 12 principles of green chemistry, and the product will be environment friendly, eco friendly, and less hazardous, and it is safe for human health as well as environment. Green chemistry is all about the reducing the waste and the materials, hazards, risk, and number of accidents are also reduced if we follow green chemistry principles. Energy efficiency should be minimized, cost. So these are all about the reducing these things. So what are the goals of green chemistry? Goals, or you can say the aims of green chemistry. The first aim is atom economy. Atom economy is basically the maximizing the efficiency of chemical reaction by designing process that utilize all atoms. Means all the reactants are to be converted into the product. All starting material is to be converted into the product. No any byproduct is to be formed. If no any byproduct is formed, then we say that this is 100% atom economy. If the byproduct is formed, then the reaction is not 100% atom economy. So, in green chemistry, we suggest those reactions that are 100% atom economical, means the starting material or all the reactant are to be converted into the product. Safer chemical synthesis, develop methods that minimizes or eliminate the use of hazardous substances, reducing risk to human health and environment. One drug that is known as thalidomide. This thalidomide drug is having two forms, and this drug is particularly used for the reducing the birth defect of children, and this is particularly given to the um, um, you can say the pregnant women or expecting mothers. So this drug is completely banned. So it research on this drug and new molecule are to be synthesized that are safer, that can be used. Energy efficiency, we are promoting energy efficient process to minimize energy consumption. There is a lot of energy is required in chemical synthesis or the chemical production of chemicals. So in this we design a process in such a way so that the energy is to be minimized. For example, we do this by microwave initiated reactions or by ultrasound chemical synthesis, solar energy methods, and all these things in order to minimize the energy. Second thing, another thing is the renewable feedstock. You know that we are here and mostly depending on fossil fuels, and these fossil fuels on burning producing carbon dioxide, and this carbon dioxide will create a problem to our society. So generally we use renewable feedstock, particularly based on the biomass and the agricultural waste. So generally here we utilizing renewable feedstock such as biomass and agricultural waste to reduce dependence on finite fossil fuel sources. The last thing is the biodegradability. A lot of work is going on biodegradable polymers, polymer composites, because the our um, many of the we are totally depending on polymers. For polymers are having, it touches every life and is having wide role in our daily life. So we design products that are easily biodegradable to minimize environmental persistence and accumulation. If it is persistent to the environment for long time, and this will create harm to the animals and polluting water also. So that's why we are shifting our approach to the biodegradable polymers or increasing the biodegradability, and this is only possible by introducing the natural materials. So many of the cases we are replacing the synthetic materials with the natural materials, but in some cases we don't get the better properties because all the natural materials are hydrophilic in nature. They can be modified either by derivatization or by some other methods, but green chemistry not favors the derivatization. So making chemical products that do not harm either our health or the environment, and using industrial process, the process and the operations. So using industrial process that reduce or eliminate hazardous chemicals, designing more efficient process that minimize the production of waste materials. So it is the role of chemist, researcher to design the chemical process, design chemical, design product, design energy efficiency, or reduce the minimize the energy efficiency. This all comes under the green chemistry part. So designing of synthesis in such a way so that waste or byproduct formation is minimum, and saving companies money by using less energy and safer chemicals. Thus reducing the cost of pollution control and waste disposal. These are the goals of green chemistry. One important part, that is the atom economy. So atom economy is basically the synthetic method should be designed to maximize the incorporation of all material used in the process into the final product. So here in the screen, it is the formula of percent atom economy. Formula weight of desired product, or molecular weight of desired product divided by the molecular weight of all reactants multiplied by 100. So by this formula, we can easily find the percent atom economy of any of the product. Any of the product we can find. So generally, this is an example here. Here in this reaction, N-methyl propionate is formed, and the molecular weight of N-methyl propionate is 87.106. While in the reactant part, ethyl propionate and methylamine is present, and you can calculate the by using the formula of atom economy is here 87 divided by 102 plus 31, that is 87 divided by 133 multiplied by 100, and this comes is the result comes is 65.41%. This is the percent economy for this reaction. The rearrangement reaction and the addition reactions are 100% atom economical, since all the reactants are incorporated into the final product in these reactions, addition reactions and the rearrangement reactions. So what are the limitations or obstacles in the pursuit of green chemistry? These are economic constraints, technological challenges, regulatory hurdles, market acceptance, education and awareness. And these, how can we come out from these obstacles? These obstacles can be overcome by the collaboration among scientists, policymakers, industry stakeholders, and the public to overcome technical, economical, and social barriers and advance the goal of green chemistry. So, by this lecture, I am creating an awareness to all the students about the green chemistry. So, in Delhi University, lot of work is going on green chemistry and green chemistry network that is to be handled by Professor R.K. Sharma sir. And lot of books are to be written on this green chemistry, so that many of the pupils, many of the students are aware about these green chemistry principles. If they are educated about the 12 principles about of green chemistry, then definitely they will incorporate in our daily life. As an individual, they will try to reduce the pollution by doing all these, yeah, adopting all these goals. Energy efficiency, the vast majority of the energy generated in the world today is from non-renewable resources that damage the environment. Carbon dioxide, global warming, temperature is rising day by day, depletion of ozone layer depleted, ultraviolet rays directly coming to the earth, effects of mining, drilling, etc., and toxics. So, in green chemistry, we energy efficiency should be minimum. So, how this can be minimized? This can be minimized by the use of microwave initiated reactions and ultrasound synthesis, some solid reactions. So, these means solventless reactions. Alternative products. So, as an individual, we identify the part of molecule that is providing intended use and part of molecule responsible for toxicity or other hazards. So, in a chemical reaction, we look into the toxic part and the hazardous part. So, we can replace this with some other chemicals that are less toxic or even environment friendly. So, reduce toxicity, sacrificing efficacy of function, eliminate toxic functional groups, make molecule less bioavailable, pharmaceutical and pesticide manufacturing, change or replace products. Many of the polymer composites are to be prepared by the use of natural fiber, polylactic acid, starch. These are the natural fiber, natural polymers. So they can easily replace the synthetic one. Alternative reaction conditions: reduce or eliminate solvents. In Green chemistry, we prefer green solvents. Basically, water, supercritical carbon dioxide, ionic liquids, these are preferred. So, our aim is to perform the reaction at ambient temperature and pressure. So, we prevent pollution by recycling and reuse, treatment, disposal, all these things are used for pollution prevention. So, green chemistry can be conveniently achieved by following the 12 principles of green chemistry as suggested by Paul Anastas and John C. Warner. What are these principles? The first is the waste prevention instead of remediation. So we will try our best so that this waste is not produced. If it is produced, then it should be treated. And this treatment requires economical burden. So we will try our best so that this waste is not created. It is better to prevent waste than to treat or clean up waste after it is formed. Atom economy, we have already explained. Use of less hazardous and toxic chemicals. Wherever practicable, synthetic methodologies should be designed to use and generate substances that possess little or no toxicity. That is already discussed. Design safer products. Chemical products should be designed to preserve efficacy of function while reducing toxicity. Products should be efficient. Does not have any harmful effect. If the particular drug is designed for preventing the vomiting, so it should prevent the vomiting and does not have any side effect. Innocuous solvent and auxiliaries. The use of auxiliary substances, solvent, separation agents should be made unnecessary wherever possible and innocuous when used. Innocuous is harmless solvent. They didn't have any harm. They are not even volatile. Energy efficiency by design. Energy requirements should be recognized for their environment and economic impacts and should be minimized. So, this should be minimized by the use of techniques. Microwave. Microwave not works for all chemical compounds. It works only for the polar compounds. If they are having polar group, then microwave is possible. Microwave reaction is possible. If they are having non-polar compound, then it is inert to the non-polar compound. Preferred use of renewable raw materials, that we have already discussed that the use of agricultural waste biomass is preferred. Shorter synthesis, avoid derivatization, but in order to improve the you can say that reduce the hydrophilicity, we generally do the derivatization part. Sometimes grafting, sometimes blocking, all these things are to be carried. Unnecessary derivation, blocking, group protection, deprotection, temporary modification should be avoided. Wherever possible, whenever possible. Catalytic reagents as selective as possible are superior to stoichiometric reagents. This catalytic reagent, if we are using, then it should be selective, and it is superior to stoichiometric reagents. In spite of using reagent, we use the catalytic reagents. Design product to undergo degradation in the environment. Product should be designed in such a way so that it will not persist into the environment for long time. If it is persistent into the long time environment for long time, then it will harm to the animals, living organisms, and all these things. So it should be degraded. Analytical methodologies for pollution prevention. The analytical methodologies need to be further developed to allow for real-time in-process monitoring and control prior to the formation of hazardous substances. Inherently safer process. This is the last one. Substance used in the chemical process should be chosen to minimize the potential for chemical accident. Many of the industries are taking care so that this accident is to be minimized. When I was working in Mauser Beer India Limited, uh, it is a multinational organization that is used for optical storage media devices like CD and DVD. So they are giving 2 hours safety precaution, and they follow the safety precautions carefully, and even guide all individuals about the safety, how this solvent is to be used, how we can minimize the accident, how you can take the solvent from a drum, and even how you take precautionary action while you are working in a chemical environment like different types of dyes. So they will prefer the mask and safety googles and all other related technologies. Even those chemists who are not following these precautionary action, they have to give a safety ticket. That is nearly about 500, 1000, depending on the rules of violation. So these are to be used to minimize the number of accidents. But in this case, we are designing the chemical process, designing the chemicals, designing the solvents, especially ionic liquids, so that this should be minimized. Here we are recommending some books and journals related to the green chemistry. You please note down all these, take the screenshot of all these books and journals. Here are the some important websites related to the green chemistry. So this is all about the introduction part of green chemistry. So this green chemistry is basically used in laundry. In many of the cases, perchloroethylene is to be used to remove the grease from the clothes. But nowadays, this is avoided. Here we have some alternatives. We can use supercritical carbon dioxide along with some polymer surfactant. They can also do the same work. So you can see that some while you go to the market, you see that in some cases that green dry cleaners is written. So they are adopting these technologies. So water purification, industrial cleaning. So these are the application part of these green chemistry. So green chemistry is not a solution to all environment problems, but the most fundamental approach to prevent pollution. If we follow these 12 principles of the green chemistry, we definitely prevent pollution, and this prevention is better than the cure. If we try to work on these principles, definitely we get results, and the peoples are safe, environment is safe, and thank you.